As I just shared, what I'd like to do is a little bit of education on the different types of machine learning that can use to reduce the mean time to detection. And the reason I chose to talk about mean time to detection is I think if you're going to leverage, machine learning or automation, you should really have a goal for why you're doing it. So I'm going to talk about how supervised machine learning, unsupervised machine learning, adaptive machine learning, and deep learning can all be used to reduce that key, metric of mean time to detection. And then I'm going to follow on that conversation with a talk about how automation can reduce that mean time to response, right? And if you're not providing these kind of metrics to your, customers today, these are great metrics for your SLAs and things like that. But when we talk about AI, machine learning is a subset of AI, right? So let's learn about the different types of machine learning so that we can be a little bit more specific and prescriptive about how we use them. So the first thing I want to share at a high level is the challenge that we all face today, right? Not only are we trying to protect our customers' networks where they have their office, but with COVID, they've increasingly been distributed out, into those private networks and private things that they leverage that Jay shared in the previous panel. So all of these things, when you add them together, open up the attack surface for the bad guys. And so what the bad guys are doing is attacking these things in combination or leveraging staged attacks. Most attacks today don't happen in one space on one device, right? Most attackers, if they were trying to steal your database, might run a big DDoS attack against you to divert your attention while they're achieving their ultimate goal. The same thing with ransomware. Ransomware cripples a company and they're so busy dealing with it, they could be losing tons of data on the back end of their network if they're not watching it properly. So what we've seen in the industry so far is a lot of these different products that cover these different areas are leveraging machine learning on those individual silos, but we don't see are tools that are able to take the signals from all of those different silos and create the overall event that the managed services provider should be concerned about, right? And this is where machine learning can actually be developed to do that. And so if we can do this one thing, in other words, build machine learning across the different threat vectors, if someone attacks an end user who's on their home network, right? And you have maybe like an EDR tool on that endpoint. And you're watching the endpoint, and all of a sudden, somebody's screen scraping a bunch of records in Salesforce, right? We saw a phishing attack against that user. We might have seen some key logging happening, but now all of a sudden we're seeing them leverage that as a launch point to get credentials to go into Salesforce, a SaaS application, or even potentially going into their primary application that might be hosted in AWS. Well, how do you correlate something that's happening in CloudTrail with CrowdStrike with Salesforce, right? That is the modern security problem. When we talk about machine learning, there are a lot of different categories of this, and it is all mathematically based. The guys that know how to do these functions are PhDs in artificial intelligence and machine learning. Now, crossing that chasm from understanding the way that these technologies can be leveraged to how they can be leveraged within security is a big chasm to cross, right? And that's where you need experienced security practitioners collaborating with the data scientists to create these models. And an example I'll give just real quick from Silence when I was there is we had a very large incident response team. Silence never had an endpoint product until the incident response team brought back enough samples to the data scientists to begin creating the models that could be more effective than antivirus, right? So, the key thing to understand about machine learning and where it's being used is you as the MSSP don't need to become experts or outsource artificial intelligence data scientists to run this in your business. And I'm going to talk about how. So the first type of machine learning, and this is what we used at Silence and also here at Stellar Cyber, is supervised machine learning. Supervised machine learning, you try to provide as many samples as possible to your data scientists of both good files and also bad files, right? So why do you provide good and bad files? It's because until you can look at both types and with a degree of confidence understand one from the other, that's how you create this model. And so once you've created the model of what's a good file and what's a bad file, when you are able to collect a log that sees this file, you can compare it against your machine learning and it will, with a very high efficacy level, determine, is this thing good or is it bad? So the example of how we leverage this in the Stellar Cyber platform is that we have a sandbox built into the platform. When we're pulling in log data from all the different sources within the customer's environment, we're pulling the metadata out and we're comparing that metadata against 15 different sources of threat intelligence. If we don't have a reputation for that file or that URL or that IP address, the next thing we're going to do is we're going to drop it into a sandbox, and our machine learning here, our supervised machine learning, will determine if that's good or bad. And in a lot of cases, we've found 0 days in Office 365, even with, some sort of mail hygiene on the front end of it. We're finding 0 days, 2 to 5 days before it's even has a reputation on VirusTotal, for example. So that is supervised machine learning. Unsupervised machine learning is a little different, and this concept here is where you put machine learning on a set of data and you have it look for anomalies over time, right? So within the Stellar Cyber, platform, we're collecting data for each customer's tenant, and we have a fully multi-tenant platform, right? But the unsupervised machine learning that we do is tenant specific, right? And why is it tenant specific? It's because you want to baseline the behaviors of the users, the network traffic, the devices, everything that's on that network, so that when we see anomalous behavior, we can flag it, right? And we can create an event, right? So let's compare that to a rules-based detection, right? A rules-based detection is either a 1 or a 0. It either tripped the rule or it didn't, right? So an example of that might be something like, failed login attempts, right? In one customer, 10 failed login attempts could be very anomalous. In a very large customer, 10 failed logins in a period of time could happen every minute, right? So what machine learning does is it baselines what's normal in that environment and says, hey, this is an anomalous number of logins. When we see someone trying to log into a server 200 times within 5 minutes at 2 o'clock in the morning, it's not usually a good thing. So there's different ways that you can, use this unsupervised machine learning, right? The first is to compare with your own history, series, and time analysis on either files or network traffic or whatever's coming into the tenant. Then you can also compare that with peers, right, within your customers to see if you're seeing trends there. And then you can cluster those, and then you can compare it with other relationships. And this is where we're going to start talking about deep learning, which is going to begin not only connecting the alerts into an event, right? But we're going to connect events into an overall incident, so that now that DDoS attack that precursored, stealing someone's database, right? We can connect those things and connect those activities and create one incident for the managed service provider to work through. So that's how anomaly detection works within unsupervised machine learning. Now, anomaly detection, in a machine learning context, as I shared earlier, there's a huge chasm to cross between, what is anomalous from a math perspective and what's anomalous from a security perspective, right? So we need not only our security practitioners to develop the application so that our partners can use it efficiently and effectively in their environment, but we also need to make sure that our partners can interact with the machine learning in a simple way. And the way that we do that is through what we call adaptive machine learning. This is where even within your customer's tenant, your security analyst will know, oh yeah, they back up their server to this offsite, data center 3 times a day at these different times, right? We may see that as anomalous, behavior based on our machine learning, but when you look at it from a, analyst perspective, they go, oh, I know exactly what that is. So now you can say to the machine learning, hey, don't discard that data, because if it becomes anomalous, I want to know about it, but suppress that event so that I don't have to look at it every day, right? So that's a very critical difference between the way that we approach leveraging machine learning in the Stellar Cyber platform and most other manufacturers, because most other manufacturers, that machine learning is black box. You don't have an opportunity to influence it. So what we're doing here is we're allowing our partners to influence and make the machine learning in our technology better in a very simple way. So it's not enough, right, to be able to find the bad files and find the bad URLs and then find anomalous behavior within the environment. But now it's becoming even more important to connect what's happening between all these different technologies, right? Whether you're using, Nessus for your scanner, or you're using Cisco or Palo Alto, or any other million different firewall vendors, different endpoint securities, different email services. How do you connect, what's happening at a user level so that it makes sense from a human perspective? And that's what we're doing right now with our incident management application that we're developing within our platform. Now, even if we don't, through a machine learning algorithm, connect these disparate events, your analysts will be able to, if they believe that they're connected. And that way you can leverage the machine learning to do a deeper analysis on those events. And, we can then, look at how this thing propagates and create very simple to understand graphs by using the neural networks within the machine learning to make these connections that ultimately you could never make in a sim, because you would need data scientists, creating rules that would be very specific for a very specific sim if you weren't using machine learning, right? And this is where, we can begin to, experience the true power of what machine learning could bring to a SOC operation. The way that we do this at Stellar Cyber is through a process that we call Interflow. Instead of just ingesting raw logs from multiple different devices, our sensors and collectors and API integrations pull the security interesting metadata out of the raw logs and put it into a standardized format. And as I shared earlier, as we're collecting this metadata, it also reduces your storage requirements, right? One of the things that we all need to, talk about at some point, and this probably isn't the, place for it today, but, storing logs is creating more and more, piles of data in data centers. And, probably 80% of it is not interesting from a security perspective. So you can still store all the logs, on these different tools from different platforms. But within Stellar Cyber, we're just pulling that metadata out. We're running it against our data analyzer to see, from our 15 different sources of threat intelligence, do we have reputations on this metadata? If we do, we add it into the metadata and we create this Interflow record. So, without having to do integrations between multiple log sources and multiple tools and writing multiple rules, what we're doing is we're creating machine learning based detections that cut across that data lake. So once it's in that standard format, we can create any detection that we want that could be specific to looking at, bad behaviors outside of the network between users and SaaS applications or users and cloud applications, right? These are things that aren't even considered by most SIMs today because we're just looking at log sources, right? And we can piece these things together and save the analyst time in understanding what's happening. Once we're able to do this, we've also built response capabilities into the platform. And the response capabilities are all based on integrations. And all of those integrations are based off of APIs that these manufacturers provide us access to. So for instance, if we see, an outbound tunnel that we want to shut down, we can send a block rule from the event right to the checkpoint firewall, from the event with an API integration. If we want to contain an endpoint with CrowdStrike, we can do that right from the actual event, okay? So what we're doing here is kind of SOAR-like capabilities. It's not as, complex or as deep as a SOAR, but it does a lot of the, simple blocking and tackling right out of the box. And when we build these integrations, we actually sign a technology alliance agreement with all of these partners so that, we're getting sandboxes from them. They're updating us when they update their APIs. And, we can maintain a very high level of support for all of these different integrations. And this is just scratching the surface. The Stellar Cyber platform is completely open. So as a managed services provider, you might not use some of these technologies, you might use something else. We can create log parsers within a week, and we can create API integrations as quickly as we can work with the manufacturer to develop them. So when you can do this, right, we can think about, how we can correlate, how we can get rid of the blind spots. And ultimately, our partners in a recent study have improved their mean time to detection at least 8x over their previous SIM solutions. And they've been able to automate and, build response and save 20x of their mean time to response, right? All of this integrates without you having to be a data scientist, right? And we can do all of this through a single pane of glass. All of this functionality that we built into the platform is application based. So when you purchase the license for the platform, all of the applications come out of the box. You don't have to buy a scanner. You don't have to buy an IDS. You don't have to buy anything. Once you buy the platform, you get all of the functionality and all of the tools included in the platform. So depending on how we're doing on time, Pelham, do I have time for just a quick demo?
Yes, you do.
Okay. So let me pull that up real quick. And I'll show you exactly how this could be leveraged within your SOC. All right. All right. Share screen. All right. Can we see the console right now, Pelham? Hopefully you're on mute. Okay. So what we're looking at here is the Stellar Cyber platform. And I'm just going to do a couple of quick examples. in how you could potentially leverage the platform, within your SOC business, right? So the first example I'm going to do is a quick one, where we had a lot of partners that called us as soon as the SolarWinds breach was announced. So what I can do here within our platform is I can go look for SolarWinds server just by typing in the name SolarWinds. And when I do that, it's going to crawl that database of Interflow records, and it's going to find that particular server, right? So here, we know that it's, in our Stellar Cyber tenant of all the different tenants, we know it's located in San Jose, but we also know that it has a very high risk score. Our risk score goes from 0 to 100, 100 being very bad. So what we're seeing here is that this particular SolarWinds server has had, in the past month, 51 different security events happening against it. What we've done here within the platform is we've built a 360-degree panoramic view. If your analyst was going out and looking for this, normally they'd have to know where the SolarWinds server is. They'd have to piece together any events that they've seen in the SIM that might, relate to it. What we do is we create that 360-degree panoramic view. Oops, leveraging the machine learning. Need to expand the horizon here. And we can see this is actually the UK server where you would get your updates for SolarWinds. And what we're seeing here is the actual SolarWinds server. What we're seeing that's really interesting is that at some point, somebody downloaded a scanner onto this, which was part of that update, and it began scanning the environment for other IP addresses. Not only did it find other IP addresses, but it started doing things. On this particular server, it downloaded 33 Trojans. On this one, there was an RDP brute force attack on the server, and they built a reverse tunnel ultimately into this particular server, right? So what we're seeing here is a correlation of all what would seem at the bottom here. These are all the different alerts associated with that server that you would maybe see in a SIM. What we're doing here is we're giving the analyst a graphic representation of exactly what happened. And we're also giving, on the left-hand side here, all the different parts of the kill chain and when those events happened. So now we have a very clear picture of exactly how that server was compromised and what happened after it was compromised. And if you followed FireEye or you followed the other manufacturers that had this breach, it took them, in most cases, a week to 2 weeks before they could provide their full reports on this. We were able to show our partners and their customers whether or not they were breached out of the box without a specific detection for this breach at all. So I'm going to bounce back out here real quick and just share one other way that we can detect events. One of the worst things that can happen is actions and exfiltration within your customer's network. And the way that we organize our console is, we've got the different levels of the kill chain, and then we have all the different machine learning based detections that correlate to that part of the kill chain. We're in the process of updating this to map to MITRE because MITRE is a little bit more specific and a little more modern. But I'll just give you a quick SQL dump file alert that we generated here. And what we're doing here with the machine learning is we're looking at, wow, there's 12 critical events that are SQL dump file related. I can go into any one of these and begin to see exactly what's happening. So here, our machine learning has a fidelity score of 100. This is highly anomalous. We do not see it in this network ever. And so it's very highly anomalous. And then from a severity perspective, we know that an outside execution of a SQL dump file is a really bad thing, right? So what we can do here, and this is where we have the adaptive machine learning, I can share this threat intelligence with our community. I can, suppress the event, or I can even exclude it from the machine learning. This is where, you can actually begin to influence the machine learning within your SOC without having to be a PhD. And then you can also take an action automatically. You can block it on a firewall, disable a user, all sorts of different things. Here, what I'll show you real quick is this is what Interflow looks like, right? It is just, this is the metadata that we pulled out of all the different devices in the environment to create this record. It is also available in JSON. So if you're familiar with JSON and like dealing with your data in JSON, all of this data is completely portable and usable in other tools. But more importantly, just the same way that I showed you the 360-degree view of what happened on an asset, I can show you the same thing on an event. In this particular event, we saw multiple login failure anomalies, essentially brute force attacks, until we see, an exploit anomaly, and then we see a successful brute force login, and then we see 14 bad files downloaded. Again, just like it did in the previous example with the SolarWinds server, it scanned the network and started, infecting other machines. And here you can see it did a dump file execution, and then it created a DNS tunneling anomaly to exfiltrate the data. And I showed you all of that within about 10 seconds. Again, this could take weeks for a SOC analyst. So this is how we achieve those, performance benefits for our customers. I guess I'll pause there, Pelham. I think I'm getting the hook to some extent, but any questions?
No, I just came on as the champion of the audience. We've got quite a nice few comments. Chris says it's the private networks that will turn out to be the terrible attack surface. I think that was earlier in your presentation. Brittany capitalized, this is the key. Walt says, how much SolarWinds related work have you had these last couple of months?
It is our partners that have worked with customers on the SolarWinds incident, on cleaning that up. We have chosen very deliberately not to provide services. So we provide the platform, we enable our partners to leverage it, and then it's up to them to run it in their business, right? So we do not, like many other manufacturers, provide incident response services and remediation services and things like that. We prefer to let our partners do that.
Understood. Well, no, that's great, because of course this event is all about the partner world, the VAR world, the MSP, MSS, and end user world all working together. And I like you brought the ML aspect to life.
Yeah, and I hope if anybody has any additional questions on that, there was some discussion earlier of, can an MS provider get to become an MSS, right? And so I think the industry has looked at it like a light switch, like you either are or you aren't, right? And it's a big chasm to cross. So we work with a lot of MS partners to help them connect the different security products they're already running for their customers and create like an 8x5 monitoring service. And then they can gradually walk their customer into a more SOC related service further down the road. So instead of, telling them, hey, you have to do all of these things to become a SOC, we can help them, stair step their way into it. Just a little different approach.
I like it. And a nice comment or question from Brittany. You touched on using a single platform for learning and quality data. How do you recommend an organization do that exercise, or what questions should they ask themselves?
Well, there are a lot of partners that I've talked with and that have become customers that were trying to use Elastic or trying to use Wazoo or some of these, open source platforms to build this themselves. The hard part about running a data lake and building the machine learning to run across it is that it takes a lot of expertise and time. We've been building this product for 5 years. And we didn't start off to be an XDR provider. We started off to try to improve, SOC performance and kind of improve on SIM, right? But as we've kind of grown, what we've found is that, the XDR piece is really important next generation technology for partners, because it helps them be open to other products that their customer might have, and to normalize the data through that Interflow process that I talked about. And then once it's in the data lake, you can do all sorts of things with it. But you've got to have a different way of collecting the data to normalize it so that it's easier to deal with. If you're just dealing with, 1,000 different log formats, you're going to be frustrated, right? So, there's a few key things that we did in the platform that make this much more usable from a partner perspective. But, again, we bring on a lot of partners who've gone down that route. They have to build their own connectors. They have to build their own math models. It's a tremendous amount of work. And, I think what we've done is kind of done that hard work for them in a very affordable way.
I like it. Great,
Mhm.
great sentiments, and great to welcome you back again. Brian, we are now out of time, but yes, thank you very much to Stellar Cyber for your continued support. And can I put your email in the chat box? Would you be happy?
Yeah, absolutely. It's Brian, Brian, at stellarcyber.ai. Yep. There you go.
Perfect. Well, please give Brian a wonderful virtual round of applause. And